What's up, Mindsetters? It is a Monday afternoon and it is Maths Monday, as you should know by now. And you're hanging out with Looney and Natasha. How are you, Natasha?
I'm very well, thanks, Looney. How are you doing today?
I'm good, thank you. What are we doing for the Mindsetters today?
Well, we're carrying on with our section on probability. We started last week where we introduced probability and the concepts, and today we're just doing some little bit, not that much, but just a little bit harder questions.
All right, Mindsetters, you heard it, probability. But you know, before we start with the lesson, I have got so much to tell you guys. Before I start with anything else, here at Traffic would like to wish James a happy birthday.
Woo!
Happy birthday, James, from all of us, and Natasha and I. Happy birthday to you. James, guys, if you don't know James, James is in our ear. So you don't know James, but we know James. And then, Mindsetters, you do know that from last week, we've been telling you about this awesome learning hub on our Samsung devices. So if you don't know about that, I'll just briefly tell you. Samsung and Mindset have partnered, guys, to give you this awesome learning hub, and we've got content, learn extra content on the learning hub. So basically what you need to do to access this learning hub is have a Samsung tablet or premium Samsung smartphone. So that's all your Galaxy S3s, your S4s, your Note 2s, and all those devices. But don't sweat it, guys, if you do not have a Samsung device, because from today until a very long time, we have a Learn Extra exam revision marathon competition. Okay, so basically what happens is that you need to download the notes from today. And remember, guys, if you do download your notes today and you get that marathon number at the end, it's there at the end, the last page, there's a marathon number, and you enter. I will post all of this information on our Facebook page. So if you enter today, you will stand a chance to be put in all the lucky draws from today onwards. We're giving away 9 Samsung tablets. So if you don't have a Samsung tablet or a premium smartphone, don't stress. We got your back here at Mindset, because we're always thinking about you guys. So make sure you download your notes and you check out that marathon number at the last page. There's a marathon number there. I will post the notes on Facebook. Our Facebook page is facebook.com/learnextra, and you can hit me up on Twitter at learnextra, and you can download the notes, but I will post them on learnextra.co.za/live. I hope you guys understand it. We've got great revision content on the Samsung Learning Hub. Remember, if you do have a Samsung device, you can get the Learning Hub on Samsung apps on your tablet and on Samsung Hub on your premium smartphone. So with all that Samsung talk and birthday wishes done, happy birthday again, James. I'll take it straight back to Natasha.
All right, well, that all sounds really fantastic, and I hope you're all entering that competition. I wish that we could, but I don't think we're allowed to. Good luck, and remember, the reason that you tune into this channel for more than any other reason is obviously to learn. So today we're talking about probability. We're carrying on with probability. We started last week. I introduced some of the basic concepts that you guys may have learned earlier in the year, depending on how your school is structuring the syllabus. But for some of you, it might have been the very first time you've seen it. What we did last week was we covered what a probability is, how to calculate basic probabilities. I also touched on mutually exclusive events, but today we're going to go into more detail. Mutually exclusive events, we're also going to look at complementary events, and we're going to calculate probabilities using Venn diagrams. All right, so some of the key concepts. As I said, I did most of this last week, so I'm just going to do a quick recap, and then hopefully you guys would have followed last week, and this is sort of now all coming back to you, and it's more revision rather than learning it for the first time. Now, remember, when all the outcomes of an activity are equally likely to happen, you can calculate the probability of an event occurring by using the probability of some event E is equal to the number of favorable outcomes over the number of possible outcomes. So when your events are equally likely, we can say the probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. Also remember, guys, your probability values will always lie between 0 and 1. And remember, 0 being an impossible event and 1 being always true. Okay, so something that will always happen will have a probability of 100%. Okay. Something else we discussed last week was the probability identity, which says that the probability of A union B, or the probability of A or B, is equal to the probability of A plus the probability of B minus the probability of the intersection. Remember that sign means intersection of A and B. All right, so the probability of A union B, we showed you last week, and we worked with that formula that you saw up on your screen there. We touched briefly on this last week, mutually exclusive events. Now, mutually exclusive events are events that cannot happen at the same time. So that is, what that means is that they have no points of intersection in common. So as I said, I touched on this last week, but mutually exclusive events really mean there's absolutely no way they can both happen at the same time. So for example, you can't get 0 for a test and pass the test at the same time. It's mutually exclusive. There's no intersection. It's either one or the other. So there's a special case of working out the probability of A or B when you're dealing with mutually exclusive events. The probability of A or B is equal to the probability of A just plus the probability of B. We don't subtract the intersection out, and it should make sense to you because remember, when you're dealing with mutually exclusive events, the intersection is 0. So there's no point in subtracting this little piece here or adding that little piece because the intersection in mutually exclusive events is 0. So therefore, once again, the probability of A union B when A and B are mutually exclusive is equal to the probability of A plus the probability of B. All right? Complementary events. Complementary events are mutually exclusive, so they will not happen at the same time. Now, if A and B are complementary events, then the probability of A plus the probability of B is equal to 1. Now, what this means is, if you think about it, let's take an event like you toss a coin. You can either get a head or a tail. You cannot get both things at one time. So therefore, the complementary event of getting a head would be getting a tail, all right, on your coin. So therefore, they cannot happen at the same time, so they're mutually exclusive, but at least one of them has to happen in any trial. So you know that if you toss a coin, you're either going to get a head or a tail. One of them has to happen. Therefore, the probability of those events, if you add them together, is equal to 1. And what that leads us to is that, say we wanted the probability of finding event A, it's simply going to be 1 minus the probability of event B. So if we're talking in the case of heads and tails, so you can either get a head on a coin or you can get a tail. So the probability of getting a head will be 1 minus the probability of the coin landing up, or landing with face up being tails. Okay, so probability of heads is 1 minus the probability of getting a tail. We also say that we can write this in a special way. So if A and B are complementary, then we can say that A, the event A, can be written as B complement. So that B with a little prime sign there, that means B complement, or the complement of B. All right. Or we can say not B. All right, so there's two ways to represent event A. It can be written as B complement, or we can write it as probability of not B. So for example, if we're looking at our example, the probability of heads is the same as the probability of the complement of tails. All right, or we can write it as the probability of not tails. Those are equivalent statements. What you will also see is if you continue to study further, or maybe if you do applied maths and that kind of thing, you'll notice another way that we write not is we put a little stroke above the A. So that's another way to say not A, or the complement of A. All right, so all of those little terminologies and that you guys may have come across before. Those are little things that you need to remember as we carry on with today's lesson. Okay, so that takes us into our first question for today. All right, this is question 1. We are told that there are 7 apples, 8 oranges, 10 pears, and 15 lemons in a fruit bowl. If a fruit is chosen randomly, what is the probability that it is either an orange or a pear And then what is the probability that it's not a lemon? Okay, now guys, the first thing you've got to realize here is that we're dealing with mutually exclusive events. Why are these mutually exclusive? Well, remember, you're taking one fruit out of the bowl at a time, right? So if you've got apples, oranges, pears, lemons, and all of that, and you just blindly put your hand in and you pluck one of the fruit out of the bowl, it can either be an apple or a pear or an orange or a lemon. It's not possible for it to be a mixture of that thing. Okay, you can't get something called an apple pear. It's not some sort of genetically modified fruit that's in that bowl. You can either get apple or pear or orange and lemon or whatever the case is. Those events are mutually exclusive. All right, so let's see how that plays into our first question. So we're choosing randomly and we want to know what is the probability that we get either an orange or a pear. Now we're going to say, let's the event O represents getting an orange. So O represents getting an orange. And then P will be a pear. Okay, have a look at, firstly, what is your total sample space? We have 7 apples, 8 oranges, 10 pears, and 15 lemons. So therefore, altogether, 7 plus 8 plus 10 plus 15, our sample space, our total sample space is 40. So the number of fruit in the bowl is 40. That's all the possible fruits that are in the bowl, okay? We're just interested in either looking at an orange or a pear. So what is the probability of getting either of those fruit? We know that how many oranges? We've got 8 oranges, so the number of oranges is equal to 8. And then we have 10 pears. So therefore, the number of pears is equal to 10. Okay, we want to work out the probability of getting an orange or, so we use union, a pear. Okay, now this is where it's important to remember these are mutually exclusive. You cannot get an orange and pear. There's no such fruit. So therefore, if they're mutually exclusive, the probability of orange or pear is just going to be the probability of an orange plus the probability of getting a pear. All right? So to work out the probability of orange, we say the number of oranges in the bowl, and we know that that is going to give us 8 over the number of fruit in the bowl, which is 40, plus the probability of a pear. We know that there's 10 pears in the bowl, and again, there's 40 fruit in the entire bowl. So therefore, we're going to get 8 plus 10, 18 over 40. All right, and then you can simplify that. Okay, or you can just use your calculator, divide them, and see what percentage you get. So we've got 18 divided by 40. So it's 9 over 20 times that by 100. We'll get 45%. So therefore, you have a 45% chance of either choosing an orange or a pear from this bowl of 40 fruit. Okay, so just below 50%. Okay, which makes sense because 18, the number of pears and oranges, is just below the halfway mark. Because remember, half of 40 is 20. So therefore, if we're just looking at oranges and pears in the bowl, we've only got 18. So it makes sense that our probability should be slightly less than 50%, which it is. Okay. All right, then they say, what is the probability that it's not a lemon? Okay, now in this case, to represent not a lemon is, it can be anything. It can be apple, orange, or pear, right? Because remember, there are 15 lemons in this fruit bowl. So all of the other fruit that are remaining are not lemons, okay? So therefore, if I want to find out the probability of getting something that's not a lemon, okay, and there's more than one way to do this, but I'm going to do it as follows. So the probability of not getting a lemon is going to be equal to the sum of all the probabilities of the other fruit. Because remember, these are all mutually exclusive. So it's the probability of getting an apple plus the probability of getting an orange plus the probability of getting a pear. All right. So that's the probability of not getting a lemon is equal to the sum of all of those. All right. So it's going to be equal to apples. Remember they told us there were 7 apples. So therefore, probability of an apple is 7 out of 40. Probability of an orange was 8 out of 40 from the previous example. And then the probability of getting a pear was 10 out of 40. Okay, so if we add all of these now, 7 plus 8 is 15. 15 plus 10 is 25. So we end up with 25 over 40, which you can simplify, or you can use your calculator. Do it on your calculator. 25 divided by 40. We get 62.5%. So there's a very high chance that, well, not very high, but it's a more than average chance, 62.5% chance that you will pick a fruit that's not a lemon, which is particularly good, especially if you don't like sour fruits. Okay, so over 60% chance that you won't get a lemon. Now there is another way to do it, because remember all I did was I added each of the probabilities together. You can also see that there are 15 lemons in the fruit bowl. All right. So what you can do, another way, and I'm not going to write it down, I'm just going to discuss it. Another way you can do it is you can say, well, if there are 15 lemons in the bowl, that means all the rest must not be lemons. So take your total 40, subtract 15, you get 25, and those 25 fruit divided by 40 will give you exactly the same probability. All right. Okay, guys, I think we've had enough to start the show and get you guys going and back into thinking about probability. I think it's enough to take a break, Looney.
All right. Mindsetters, let's take a very quick break, but we'll see you straight after this. Welcome back, Mindsetters, from that break. If you've just joined us, we're hanging out with Looney and Natasha, and we're going through probability. I did tell you guys about the Samsung competition that we have running, where we'll be giving away awesome tablets. So make sure you download your notes, and I will post the link for the entry form. Okay, guys, make sure you enter today, because you'll stand a chance to be entered in all the lucky draws to get one of those 9 Samsung tablets. So please enter, and please download the notes. I did post the link on the Facebook page. So with all that said, Natasha.
All right, guys, so before that break, we looked at a basic probability question dealing with mutually exclusive events, and I showed you how to work out the probability of 2 events that were mutually exclusive. All right. Now we're going to look at using Venn diagrams to help answer questions on probability. It is a very important section. It's one that a lot of people get quite muddled up about. You know, they're not quite sure how to tackle Venn diagrams. Now, you do have an option when it comes to calculating probabilities, especially when you're dealing with more complicated questions. You can put them into tables and answer your questions. You can use Venn diagrams, and then later on next year, especially when dealing with really big events or very big outcomes and trials and that kind of thing, we use something called tree diagrams, but that's only for grade 11. Some of you might have seen it, but we don't really use it to its full potential in grade 10. You'll use it much more, tree diagrams that is, when you get to grade 11. So what we're going to do now is I want to show you how you should be dealing with your probability questions in grades 10, and the best way to answer them is using Venn diagrams, especially the tricky ones. All right, so I'm going to show you how to set up a Venn diagram in this question too. Okay, so we're told that in a class of 38 learners at a girls' school, 24 play hockey. So we've got 24 playing hockey. We have 30 that are playing netball, and 4 play neither sport. All right, that's important. If a girl is chosen at random, calculate the probability that she plays, and then they give you all the options. And the first question asks us to find the probability that the girl plays hockey and netball. Now the first thing you need to realize, guys, is that these events are not mutually exclusive because you can play both sports. So there's going to be an intersection of the two events. Okay, it is possible. Just think about your school. Remember, probability questions are really very practical, real life applications. Think about the number of sports you play. There's no restriction on the number of sports you play. Those are not mutually exclusive events. All right. So we've got 38 learners. We've got 24 playing hockey, 30 playing netball, 4 playing neither sport. And they want us to find how many girls play hockey and netball. So in other words, they want us to find the intersection. Now to set this up, all right, I'm going to start immediately to answer all of these questions, and you'll see it becomes really easy once we have the Venn diagram. Okay, so I'm going to set that up before we answer any of the questions, even though it's possible to get the first answer without using this diagram. All right, so we have 38 learners altogether. All right, so that's 38 is the total. They tell us that 24 play hockey. All right, they tell you that 30 play netball. Okay, let's have a look. 30 play netball, and 4 don't play anything. They don't participate in any sport, so they play no sport. Okay, or certainly not hockey or netball, the two that we are considering. All right. So they don't play either of the sports. Now we want to find out what the intersection is. So I'm first going to show you how to set up your Venn diagram, and we'll go back to working out this intersection. All right. So in your Venn diagram, we have sort of a big rectangle that's going to enclose the entire sample space. All right. So that's our Venn diagram. Let's just make that a little bit smaller. There we go. All right, doesn't need to be completely accurate. It's just a drawing so that we have more or less an idea of what we're going to be putting inside these figures. So we've got 2 circles. Again, doesn't need to be accurate. Got 2 circles. There we go. And let's just move these into place. All right, let's try that again. There we go, and we know that these two are intersecting. All right, this one refuses to be moved. Let's try again. There we go. Okay, then we know that this entire green space, right, that's going to be your sample space. Okay, one of these circles is going to be hockey. The other one is going to represent netball. Now, everything that takes place, all the given information has to be represented in your Venn diagram so that you can answer the questions. These 4 that don't play either of the sports, they're just going to sit outside in a random little space there to say that they're not included in these 2 circles because neither of them play hockey or netball. When you set up your Venn diagram, guys, the most important thing, or where you need to start, the easiest place I find for you to start, is you first need to work out this intersection. Once you have a number to fill into that intersection, it becomes really easy, depending on the information you've been given, but it becomes really easy to then answer all the questions that follow. All right? So how do we work out this intersection? Because that's basically the first question, right? Well, have a look. They tell you that there are 38 learners in total. Now, if 4 people play neither of the sports, what that means to you then is that 34 must play either of the sports. So 34 people must play either hockey or netball. It makes sense. Hey, 4 don't play either of the sports. So therefore, the 34 that are remaining will either play hockey or netball. Now, let's set this up. We know that in total, the number of girls that play hockey or netball is equal to 34, right? We know that the number of girls that play hockey is 24. We know the number of girls that play netball is 30. If we just simply add those, 24 plus 30, that's 54. That's already greater than 34. So that's not going to work for us because altogether, the number of girls who play hockey plus the number of girls who play netball must all equal 34. So therefore, that overlap, what we need to subtract out will be the intersection of the two. All right, that has to be the intersection. So I've got 24 plus 30 is 54. 54 minus 20 will give me the 34 girls who play either hockey or netball. So therefore, my intersection, hockey and netball, must be 20. All right, so I said the total number that play hockey or netball must be equal to the number of girls who play hockey plus the number of girls that play netball minus the intersection of the number of girls that play both sports. So therefore 20 is the number of girls that play both hockey and netball, and that's the number that we put in the center, in the intersection of the two circles. All right, once we've got the intersection, the rest becomes easy. Okay, so we've answered the first part. How many girls play hockey and netball? We know that that's going to be 20. All right. So they said, though, calculate the probability that she plays hockey and netball. So yes, 20 girls play hockey and netball, but what is that probability now? So we know the number of girls is 20. If I want to work out the probability, I'm going to say, so this is part A, the probability of playing hockey and netball is going to be 20 over the number of girls, which is 38. All right, I prefer writing these in percentage forms. So we do 20 divided by 38, and we times that by 100. So we get 52.6%. So 52.6% play both hockey and netball. That's the probability of the girls playing both sports. The next one. Find the probability that the girl chosen plays hockey only. Now remember, 24 girls play hockey. But of that 24, 20 of those will play both sports. So that means 4 must play hockey alone, right? Or only hockey. And then we know 30 girls play netball, but 20 of those 30 play both sports. So therefore 30 minus 20 gives me 10 girls that only play netball. All right. So therefore the probability of a girl playing hockey only, okay, so this is part B. The probability of a girl playing hockey only, let's just go back up there. Hockey only, right, is going to be equal to 4 out of 38. So 4 girls out of 38 just play this one sport, and we can again change that to percentage. And we get 10.52%. 10.5%. All right, but this is what I'm saying to you is once you have this little Venn diagram, it becomes really, really easy, really, really simple to just simply read off your answers and calculate your probabilities from your little Venn diagram. Okay, so once you understand how to draw the Venn diagram, these kinds of questions become really, really simple. All right, so this is now part C. What is the probability that a girl plays neither hockey nor netball? Well, that's pretty simple because they told us 4 girls don't play either of the sports. So therefore the probability of someone playing not hockey and not netball is going to be, or we can write this as probability of playing neither sport, which is probably a better way to write it, is going to be just what's left outside. Remember, outside of your circles, it was 4 girls that played neither of the sports, and they told that to us. So this is just going to be 4 over 38, which will be the same as the percentage above it, which was 10.5%. All right, and then part D, we need to know how many girls play hockey or netball. All right, so the probability that you play hockey or netball. Okay, so these are not mutually exclusive, so we use our probability identity. So the probability of playing hockey or netball will be equal to the probability of playing hockey plus the probability of playing netball minus the intersection. And guys, it's important to minus that intersection, because if you don't minus that intersection, as I've shown you in your Venn diagram, you're going to double count things. You need to subtract that little piece in between. Otherwise, you're going to add that 20 into both sides, and then you're going to get horrible mistakes. Okay, so the probability of someone playing hockey or netball is equal to the probability they play hockey plus the probability of netball minus the probability of the intersection. Okay, so I'm going to do it all over again, even though we can literally just read it from what we've done. The probability of playing hockey was 24 out of 38 plus the probability of them playing netball was 30 out of 38 minus the probability of the intersection of both of those, which was 20 of them that did both sports. So we subtract that out, and we're going to end up with 54 over 38 minus 20 over 38, and that's going to give us 34 over 38. Okay, and we can once again work that out as a percentage. 34 divided by 38, and that will give us 89.5%. So that's 89.5% of girls in the school that play either hockey or netball. All right. Okay, guys, so key concepts here. How to draw a Venn diagram. If you know how to draw a Venn diagram, answering questions where they want intersections and all of that kind of thing, as you're going to see in the next example that follows as well, it becomes really, really easy. But you need to have an understanding of how to draw that Venn diagram. Luni, do we have any questions before we go to the break?
Yes, we do actually. Let me just quickly. Okay, cool. A question from Ribaone Molosiwa. How do you know that the probability of hockey and netball is 20? Because the question didn't tell us that the probability of netball and hockey is 20.
Okay. That just tells me that someone who wasn't paying attention from the beginning of this specific example, because remember I showed you how to work out that 20. It wasn't given to you. You need to work it out. So how do you work it out? You use the fact that they tell you that 4 people play neither sport, right? If 4 people play neither of the sport, that leaves 34 that will play either hockey or netball. We also use the fact that of that 34, we know 24 play hockey, 30 play netball, and I showed you down here how I was working it out. I said, well, in total, we get 34 people. We know 24 play hockey, 30 play netball. So some amount, because 24 plus 30 is 54, that's already bigger than 34. So that extra bit, that extra 20 people must be the intersection between the 2 sports. And that's how we worked out that the number of people that play both sports was 20. Okay, so that I did discuss, and we're going to use a similar concept for the next question that we answer. I think we should take a quick break.
Okay, cool. Mindset says we are going to take a break. but I see that a lot of you have questions. Okay, not a lot, 1 or 2. But we will look at them during the break and we'll get straight back to the lesson after this. Welcome back, Mindsetters, from that break. Just a quick shout out to Blessing Garabompo Rikionetebe. Wow, your name, girl or boy. Spusiso Daniel Litlhogonolo Ribaone Apiwe Dr. Ngobeni, Lorraine, Tammy, and Mandisa. Shout out to you guys. Thank you so much for tuning in. Guys, I did post the link for the entry form for the Learn Extra exam revision marathon competition. It is on our Facebook page. Go check it out. I did post the notes because that's what you need in order to get your race number. I posted the notes for your race number and the link to enter the competition. Make sure you enter today, right now, so that you stand a chance to go through all the lucky draws, because you're only accepting a limited amount to enter into all the lucky draws to stand yourself a chance to win that awesome Samsung tablet. So Natasha, with all that said, straight back to you.
All right. Okay, guys, so we're looking at one more question on using Venn diagrams to calculate probabilities. Some of you had some questions on how to work out the intersection in that, and hopefully this question will clear up those problems that you had. All right, so we're told that customers at a shop were asked if they had bought milk, meat, or both. They questioned 150 people, and the answers were 125 bought milk, 85 bought meat, and 70 bought both. So they then say, how many bought neither milk nor meat? Okay, so we've got 150 customers in total. So our total sample space is 150. We know that the number of people that bought milk, which I'm going to call MI because we've got milk and meat and they're both M's. So the number of people that bought milk is 125. And then the number of people that bought meat, which we'll call ME, was 85. They also tell you that 70 people bought both. So the intersection, the number of people that bought both meat and milk, is equal to 70. All right, they ask you how many bought neither milk nor meat. All right, so it's just a simple matter of subtraction and addition here. We know that 125 bought milk, 85 bought meat, and 70 bought both. Now, if you simply just look at if we subtract the intersection out of those two, let's see what we're left with, right? So if I've got the number of people that bought milk, which is 125, plus the number of people that bought milk, which is 85, it's 210. Already that's way more than the 150. So we subtract out that intersection of 70 people that bought both, because obviously they're going to be double counted, and we get 140 people. So that means, so if we have a look, we've got 140 people that bought, so this is the number of people that bought milk or meat. So the number of people that bought milk or meat is 140. So therefore it stands to reason that the other 10 to make up the 150 bought neither milk nor meat. So therefore the number of people that bought no meat or no milk. All right, I mixed up my abbreviations there. The number of people that bought no milk and then the number of people that bought no meat is going to be equal to 10. I've also interchanged the complementary signs. The one that you guys will be used to is going to be, let's try and erase that. There we go. The sign that you use is the little prime to show a complement. Okay, so the number of people that bought no meat and no milk is equal to 10. Again, it was just a simple matter of adding what we had together to see if we could work out the number of people that bought either milk or meat, then obviously the remainder bought neither of those products. Okay, it makes sense, right? They then say, draw a Venn diagram to illustrate the information. Okay, so let's get cracking with our Venn diagram. Okay, so remember the rectangle encloses your entire sample space. All right, and then we draw two circles to represent each of the events. Okay, my circles are not perfect circles, as you can see. All right, let's get rid of that. See. Okay, and I just want to make that intersection slightly bigger. All right, so we have sample space S. We know that 150 are being questioned. Now remember, I told you when you set this up, always start from the intersection. So I've got milk on the left hand side, and then we've got meat. Okay, or if you're looking at your screen, right hand side is milk and left hand side is meat, right? We start by filling in the intersection. That's the first thing we do. They told us 70 bought both products, so therefore the 70 goes in the middle. Okay, and we then work outwards. All right, another easy number to fill in is the number of people that bought neither of those products. So the 10 people, they'll just float around within your sample space because they bought not milk and not meat. They bought neither of those. All right, now remember, you know that 125 people bought milk, but of that 70 bought both products, so they're going to have answered twice. So therefore 125 minus 70 will give us the number of people who just bought milk. So therefore 55 people bought just milk. All right. Similarly, we know that 85 people bought meat, so therefore 85 minus 70 will give us 15. 15 people who bought meat only. All right, so this is a key part. Once you've got this Venn diagram, it really does become very, very simple. So I'm going to go over this Venn diagram very, very quickly. Remember, you use a rectangle to show your enclosed sample space. When you add up all of these numbers inside this rectangle, it needs to give you your total number in your sample space. And here we knew there was 150 people. If you add all of these numbers together, you should get to 150. All right? We use one circle to represent one of the events you're looking at, in this case milk, and then meats we represent with another circle. We start by filling in the intersection, which in this case they told us was 70, so we put that in the middle. And then we take given information, subtract out the intersection portion to give you the number of people who bought milk only and then the number of people who bought meat only. Okay. So that's our Venn diagram, really the most important part of the whole question. Get this right and you've got no problems. Okay. They then say, what is the probability that a randomly chosen customer bought meat but no milk? Okay, so in other words, they bought meat only. Okay, it makes sense because if they've bought meat but no milk, we can't include this intersection because the intersection includes people that bought both products. So we exclude the intersection. So in other words, another way to interpret this question is they're asking us how many people, or what is the probability that a person bought meat only. Okay, that's another way to say that. All right. So therefore, the probability that they only bought meat, really easy to read off once you've got your diagram, is going to be the number of people who bought meat only, which is 15, divided by the total number of people, which is 150. All right. And let's see what we get there. So we've got 15 divided by 150 gives us 10%. Right, so therefore 10% of people, that's the probability, 10% of people bought meat only. All right. Okay, and then the last one. What is the probability that a randomly chosen customer bought meat or milk? All right, so guys, again, be careful here. Remember to think about your mutually exclusive and your other events. We know that an event is mutually exclusive if there's no intersection. So obviously, with these events, there is an intersection, so they cannot be mutually exclusive events. So what all this means is you can't just add the two probabilities together. You've got to subtract out the intersection using our probability identity. All right, so this is now part 2. We're looking for the probability of them buying meat or milk. All right, so this is going to be equal to, as I said, from the probability identity, the probability of buying meat plus the probability of buying milk minus the probability of buying both. All right. So we know the probability of buying meat, so we go back up, we see, well, how many people bought meat? It was 85 out of the total number of people, which is 150, plus the number of people who bought milk, which was 125 over 150, and you subtract out the probability of your intersection, which was 70 over 150. And let's see what we get. So we've got 85 plus 125 minus 70. That gives us 140. So this is going to be 140 out of 150 people that bought either milk or meat. So as a percentage, that should be very, very high. It's going to be 140 divided by 150, which is 93.3%. Okay, and that makes sense because obviously we've got quite a large number of people that are buying both products. All right. Okay, so we've come to the end of our last question for today, and hopefully the main thing that you guys take out of these last 2 questions is how to draw that Venn diagram. It really is a key component to answering your questions correctly, especially as they get trickier. Next year, you will learn how to do 3 diagrams, and that sometimes makes a question simpler, but you need to know your foundations, you need to know your basics, and you have to be able to apply using the Venn diagram to answer probability questions. On that note, we've got a minute or so left. Luni, do we have any questions?
Yes, I'm not sure if you're gonna get this one, but it's from Lula Manzinisa, and she's asking, how did you get that 4 in answer number C? I'm not sure which question she's talking about.
Okay, well then that's a bit difficult.
Okay,
the number 4 in the answer C. Okay, well this one doesn't have a C, does it? It does, but I think she's talking about
maybe the previous
question.
Yeah.
How did we get the 4? Again, I'm not sure which 4 she's talking about because we've got a couple there, Looney, so that's not going to be a question that we can address because we do have more than one 4 in our Venn diagram.
Okay, and one more from Ngobingwenya. How would we work it out if X number of people neither play hockey or netball?
If X number of people neither play. So if they don't give you, guys, so what he's talking about is in our previous question, they told us that four people play neither sport, all right? They'll have to give you a little bit more information then. If they leave this bit of information about the 4 playing neither sport, they either have to give you an intersection or they need to give you a little bit more information so that you can work out your intersection or how many people play neither sport. But you would have to be given either more information or the intersection in order to work this out. It's not good enough to say X number of people. Okay, because then you can work it out in terms of X's, but then you can't actually find a solution to that.
All right, thank you, Natasha. Mindset is, remember that I did post the link to enter the competition and the notes. So you remember you need to download the notes to stand a chance to win yourself one of the amazing Samsung tablets. And remember, you must download the notes. There's a race number at the bottom of the page. You enter that into the entry form that I did post on our Facebook page, and you might stand yourself a chance to win that awesome Samsung tablet. Okay, we're giving away 9 of those, so make sure you stay glued to your screens and you watch our shows just in case you get more information about the competition. It is the Learn Extra Exam Revision Marathon Competition. That very long name for that competition. So make sure, guys, you do enter. If you do have a Samsung device, either a premium smartphone or a Samsung tablet, you can access the Learning Hub on your smartphone. It is on the Samsung Hub. You search for Learning and you'll find the Learning Hub there. You go to brands, Mindset Learn, and you will check out all our awesome content over there. And then on your Samsung tablet, it's under Samsung apps. Search for Learning and you'll find the store there, and you'll find Mindset Learn with all that awesome exam revision content from us, guys. It is a goodbye, and thank you so much for tuning in. Until next time, we'll see you then.